In this video you will learn in 5 minutes the basics of the resistor color code and how to use it for different types of resistors. These are resistors. These resistors have no markings, therefore it is not easy to find out the resistance values. Therefore, early in the 20th century, the Radio Manufacturing Association created the electronic color code to quickly identify resistance value and tolerance. Now, how to read the color band? The color bands represent different values. This table, which is also available on resistorguide.com, is very useful to decipher those values. Note that the colors from red till violet represent the color spectrum. This makes it easier to remember the sequence of colors. The color spectrum you can see when white light shines through a prism or when you see a rainbow. You can try to remember that you start with black, the absence of all colors, then brown, then the rainbow colors, followed by gray, white, gold and silver. Another way to remember the sequence of colors is to use the so-called mnemonics. An example is, better be right or your great big venture goes west. Many variations exist, some more memorable than others, and some might not be appropriate for classroom use. Some bands indicate the significant digits of the resistance value, a multiply factor, the tolerance, or for special resistor types the temperature coefficient or fill rate. Now we will take a look at a resistor to show how the table can be used to read the code. Let's take an example. This is a 4-band resistor, the most common variation that exists. The first band represents the first significant value. By using the color code chart, we find that the first significant value for a green band has the value 5. The second band represents the second significant value and has the value 6. For a 4-band resistor, the third band is the multiply factor. Red means a multiply factor of 100. The fourth band represents the tolerance, and gold means a tolerance value of 5%. The resistor has a value of 56 or 56 times 100 or 5600 ohms with a tolerance of 5%. We know that the green band was the first band and not the golden one. The increased space between the third and the fourth band indicates the reading direction. Furthermore, the first band cannot have a golden color and therefore the green band must be the first band. If the fourth band is not colored, we have a 3-band resistor. By looking in the chart, we see that the non-colored band means that the tolerance of the resistor is 20%. The resistance is still the same, but the tolerance has changed. Nowadays, this is nearly not used anymore. For example, in antique radios you can find 3-band resistors. Lower than 3 bands does not exist, with one exception: a 0 black band. This is also called a 0 ohm resistor. Let's consider a 5-band resistor. The extra band is sometimes added for high precision resistors. Instead of 2 significant digits for the resistance value, this type of resistor has 3. So, the first 3 digits represent the significant values of the resistance, the fourth the multiplication factor, and the fifth the tolerance. Again, we use the color code chart to solve this example, and the solution is 147 ohms with a 0.5% tolerance. This is a preferred value from the E192 series. An exception to this is the 5-band resistor with a 4th band of gold or silver. In this case, the 4th band represents the tolerance, and the 5th band the temperature coefficient of resistance. Using the chart, we see that this resistor has a resistance of 1.4 kiloohms with a tolerance of 5% and a temperature coefficient of 20 parts per million per Kelvin. It is always a good practice to check the specifications of the manufacturer for any special rules to read the code. Even resistors with 6-band exist. Normally the bands represent the first significant value, the second significant value, the third significant value, the multiplying factor, the tolerance, and the temperature coefficient of resistance. However, for military specifications, sometimes the failure rate is used. The different values can be read from the table, and the final resistor value is 3210 ohms with a tolerance of 5% and a temperature coefficient of 50 ppm per Kelvin. If you want to know more about the resistor color code or other resistor standards, take a look at resistorguide.com. Beside the color code table, you will find a handy interactive application to quickly identify resistors.